Hello. Today we're gonna see if we can make the process of building data products a bit faster by using natural language. This is the overview of what we're gonna talk about. A producer. I'm gonna describe what kind of data product I want, in what services, from what source, and give as much context as possible to my copilot. And I'm gonna get a data product at the end. Because the process will take a couple of minutes, I'm gonna actually start the process first on this demo, and then we're gonna explain what's happening behind the scene. So I'm explaining where is my source of data. This is Amazon reviews. I'm gonna give some high-level instruction on what kind of data I'm looking for, and I'm specifying to expose it on Snowflake and apply all the policies that apply in this mesh and create expectation on the schemas. This is as much as content I want to give to the Copilot. If I let this go, this, as you can see, is trying to fetch the data and try to reason about this. While this is running, so let's see what's happening. Like right now, we started from a starting point of, okay, I have some random set of data somewhere, but there are different starting points that you can imagine. One starting point might be, I am doing it from raw data, which we just talked about, but another one might be, I already have some existing ETL code that I'm trying to bootstrap as a product. If you have watched our launch video, we do cover a medallion architecture migration from this one. And then, or maybe I've run some notebook as an experiment that gets data from multiple data products, and now I want to publish the result of the analysis as a data product. So these are different starting points. Right now, we're just focusing from some data dump on some sort of a storage, and I'm trying to package it as a data product. I'm telling my Copilot to bootstrap from the source, and at the end, when I get the data product, just as a refresher, it runs as a running service, and it manages its own provisioning of infrastructure. It also, as an API, publishes the metadata, health, and metrics. It has its own self-orchestration based off the input data, if the data changes or if there are schedules related to upstream changes. And it enforces the contracts and policies. We kind of give a hint to the agent around put some placeholders for this based on upstream data, and provides multimodal outputs, which in our prompt we said, just for nav1, just put it on a Snowflake for serving, for example, for analytical use cases. And in order to build a data product to do all of these things, there are 3 steps to that if we really want to simplify it. Step number 1, what are my semantic models? In this example, we are using Amazon reviews, like basically humans writing reviews about products on Amazon. And that's the semantic model, which is a storage agnostic representation of the data. The semantic model defines how do you want to sample it, what's the description, what's the schema, what are the relationships to other semantic models or other models across different domains, and what are the data quality and verifications that apply to this, regardless of how and where it's stored. The second thing that we need is a specification file or a spec file that gathers all the different aspects of a data product together. So here's a structure of a spec file. It defines a transformation, that this can be a simple Python file, or it can be a Databricks asset bundle, or a DBT project. What are the different inputs of upstream, where is the data is coming from, and what are the expectations on those, and what are the outputs at different ports that this data is being published to, and what are the control and access policies that are applied to this product. That's step number 2. Then step number 3, launch it. So this is on CLI. If you launch a product, you get some sort of a URL. That's a running service that does all of the things that we talked about a minute ago: provisioning of infra, publishing the metadata, orchestration, applying policies, and data quality. And if we go back and see what has happened so far, we should have put it on auto edit on, because this will take a while. I'm not going to let you sit through this. I ran this right before recording this demo. The same thing here. So you see it has been going on for a while, and you see it read parts of the data. It's trying to reason it. It uses DuckDB internally to reason about the sample of the data to understand the shape of the semantic model. It has access to the different infrastructure underneath for my logged in user to see which Snowflake on which cloud, which credentials. It is reading our Python DSL structure. So as a platform, we provide different ways for different personas to produce products. We have YAML-based structured Python DSL structures. We have a low-code GUI way. You have also APIs to do that. In this example, we're using the Python DSL. It's creating the folder and the data and the spec file. And it's trying to reason about the different parts of it. And it keeps doing this and tries to launch and validate it until it gets it right. Let's scroll on. Now it's trying to launch it and try to see if it's actually working or not, and if it's doing the thing that we said in the prompt. So let's actually switch and see what it has actually created, and let's review together. So we're looking at the Amazon reviews data product that has been generated. Not the best name, but I guess because the data was from 2023, you can change that later. There are 3 things that I want to highlight on this code. One is the transformation code. As you can see, it has injected the output that we talked about. It's going to be exposed on Snowflake. It has provided sample reviews, like as a structure for data. With or without Nextdata, you will have a version of this transform. As I said, this can be a simple Python file or a Spark job or a SQL file. Let's look at the semantic model. You see the Amazon reviews. It has created the schema, some verification code on the data quality, and some sampling. and then the spec file where everything comes together. So you have some metadata of the data products. You have the input, which is reading the data from ADLS where we specified. It has some expectations as a placeholder for your upstream data as we specified. Transform, which is a reference to what we just talked about on the Python transformation simple code. And the output, which happens to be a snowflake, only one port for now. But you can add more ports to this if you wish. And it has already given access to Hello Nextdata because it looked at other sample data products and interpolated that most of the products that I'm launching have the same users. So it kind of suggests the same thing. So let's go ahead and launch this. So if I go to integrated terminal, launch, what's going to happen? It's going to look at this file. It's going to bring up the, so if I go back to this slide, it's probably going to be, let's review it. It's going to bring the provisioning. So if, for example, on a Snowflake, I need a new schema, new tables, new warehouses. It will provision those. Publishing of metadata. This is the API that publishes the semantic model that we talked about, or when the first time the data runs and gets materialized, it will publish number of rows changed, what was the health of this, the result of the orchestration. So this is about, okay, my new update is arriving from upstream. I'm going to listen to those things. That's while we are launching the product, these are the kind of resources that are being provisioned for the autonomous data product to be able to run autonomously. So let's make this a bit bigger. So it seems like it launched it and then it failed to start. And if we do mxd describe data product and we give it the name, we'll see what has launched. So you see that it's in a failed state. It has an endpoint in here. So let's go to this API. Different APIs that this multi-channel state is exposing. You can see the inputs. You can see the different outputs and how to get like these are the mutations that you can do to get connections. You can get the events. You can get the policies. It might be easier to navigate to a user interface for this. It might be a bit easier. So if I go here and I search for Amazon, it's this one. You see it's in the failed state. I'm going to get that for a second. So you see it has the semantic models that we talked about, who is doing what product has what review. It has the inputs from ADLS. Oh, I shouldn't click on it. And then it has outputs on Snowflake. It has expectations from upstream and set of promises. And you see in the policy section, ensuring no PII has failed. So globally, someone has defined a policy that any data product that is in this domain should not have public PII data. And because in the sample data, it has found PII data, it's right now failing it, which requires manual intervention to go and see what is the global policy and why are we not satisfying it. The next step would be to go and figure it out. But that's not the point of this video. The point of this video was because we have done the definition of semantic models and spec as a simple DSL language, it turns out that LLMs are actually really good at generating those. And as a result of that, you can do things like this. You can say, here's the spec of my product in natural language, give me one. And it makes the 0 to 1 a bit easier to get started and launch data products. Thank you very much. Talk soon.